I'm Anil Kumar. I've already created many videos to evaluate limits using Lee-Hospital's rule. Now in this series of videos, we'll take up very general cases and actually review the concepts. And I hope at the end of these videos, you will really understand what we had been talking about. The question here is, given limit of f of x as x approaches a equals to 0 and limit of g of x as x approaches a is infinity. So we are taking two functions and we are treating both of them as both are continuous functions. Right? Let me add, both are continuous functions. Okay, now the question is, can Lee-Hospital's rule be applied to evaluate limit of g of x over f of x as x approaches a? So that is the first question. We are given that as x approaches a, g of x approaches infinity and f of x approaches 0. So the question for you is, can Lee-Hospital's rule be applied to evaluate limit of g over x over f of x if x approaches a, right? Second question is, provide example to show the possible values of the above limit can take. So part B is, provide examples to show the possible values the above limit can take. So this limit can take. So these are two parts of a question. I'd like you to pause the video, answer the question. Okay, let's begin with the first part, which is, can Lee-Hospital's rule be applied to evaluate limit x approaches a for g of x divided by f of x? Now let's look into it. So we have limit x approaches a of g of x over f of x. Now what are we given? We are given that as x approaches a, f of x approaches 0. So this is 0 in the denominator. And g of x approaches infinity. So what we have is infinity over 0. Now the question is this indeterminate form, right? So we say no, it is not an indeterminate form, right? So that is important to understand. So what are indeterminate forms? Indeterminate forms are either 0 by 0 or infinity over infinity. It could be plus minus, that doesn't matter. But 0 over 0 and infinity over infinity. This kind of combination is not the one which will qualify the quotient of these functions for application of Lee-Hospital's rule. I hope this part is clear, right? Now the thing is, let's look into the second part of this question, which is, provide example to show the possible values the above limit can take. So what values can it take? Now this is kind of an open question. You can think about any function and provide the possible solutions, right? So what I'm thinking about is maximum. There could be 3 possible solutions, right? Now what could these solutions be? We're looking into limit of quotient of g of x and f of x as x approaches a. Now the possible solutions could be, we could get the answer as positive infinity, we could get answer as negative infinity, or we may get does not exist, right? So these are, actually speaking, 3 possible scenarios. Now if these are the 3 possible scenarios, can you provide me with some examples? Here is the one. Let us say a equals to 0. That means limit of this function is approaching 0. And let's define our function. We want at 0 g of x to be infinite. So let me write this as 1 over x squared. So it becomes infinite. As I put 0 here, g of x becomes infinite, right? And about f of x, I want limit to be positive, so I'll keep this also as let us say I want to make it 0, right? So x squared, so that will be always positive. Is that okay? So now if that is my function, g of x as 1 over x squared, f of x as x squared, if I substitute, what do I get? I get limit x approaches a 0, so I'm writing 0 here. G of x is 1 over x squared divided by f of x, which is x squared. So I get what? I get limit x approaches 0 for a function which is 1 over x to the power of 4. Now x to the power of 4, when I substitute 0, will always be 1 over 0, and that will result into infinity, right? So we get infinity as the result of this limit. I hope you appreciate it, right? Now actually you can pause the video and provide me with similar examples where the result will be negative infinity or does not exist. Okay, here is a simple one from what we learned. So we could have a equals to 0. We could have g of x same as 1 over x squared, and we could have f of x as equals to simple minus x squared, right? So it's not a brainer. I mean, just f of x is minus x squared. Of course, then the question will be, let me rewrite this question here as limit x approaches 0, and what we have here is 1 over minus x to the power of 4, correct? So basically I'll write 1 over x squared. Okay, let me rewrite. So we could say that the function will be limit x approaches 0, 1 over x squared divided by minus x squared, correct? So that gives you this. Perfect. Now if I substitute 0 here, what do I get? I get minus infinity. Perfect. Now, how do I get does not exist kind of a thing? Can you tell me that? Well, we could do like this. We can say a equals to 0, g of x equals to 1 over x squared, and f of x equals to, let us say, x. Now, how does this change the scenario? Now, the same limit could now be written as limit x approaches a is 0 for us, g of x is 1 over x squared, and f of x is x. So that gives you limit x approaches 0 of 1 over x cubed. Now, look here. If I'm approaching from negative side, so if x approaches 0 from the negative side, then the function approaches negative infinity, right? Because x cubed. And if x approaches from the positive side, then y approaches positive infinity. So that means different infinities, right? That means it does not exist. So what I'm trying to say here is that if f of x and g of x are as defined, and if we have quotient of these functions, then we have a case infinity over 0. In such a case, we cannot apply L'Hospital's rule, and we can actually directly find its limit without applying this rule. That's the good part. The second part is that this could have different solutions depending on what kind of function has been defined. So, as I've shown here, we could get result of this limit as positive infinity, negative infinity, or does not exist. So that is the conclusion of this video. I'm Anil Kumar, and I hope you appreciate it. We'll take few more examples where we'll discuss at length and understand the L'Hospital's rule as such. I'm Anil Kumar. You can always share and subscribe my videos. Thank you and all the best.